Okay, we're going to walk through an example here that shows us how to use the empirical rule. And in order to use the empirical rule, the data has to be, or I should say the distribution has to be a certain shape. And the distribution needs to have a bell shape. And some of those words that we're looking for is, of course, bell shape. Sometimes it's called a normal distribution, or symmetric and mound-shaped, or symmetric in one peak. Any of those words that describe this kind of a bell-shaped curve indicate to us that we're able to use that empirical rule. So it's important to verify that that's the case. Otherwise, the empirical rule won't work. So in this example, it says a 4-unit class should spend an average of 12 hours studying each week. A survey of 27 students showed that the distribution of study time was bell-shaped, and here's those important words that we were looking for that enables us to use the empirical rule. The distribution of the time was bell-shaped with a mean of 14 hours and a standard deviation of 3.4 hours. And we're going to use the empirical rule to find the following information. Okay, now because we know it's bell-shaped, I have this kind of a shape when I draw my picture. The mean always goes in the center. And I know that the mean, because it was given to us in the problem, is 14 hours. And the standard deviation, I'll write this off to the side, we were told in the problem was 3.4 hours. So what that tells us is that every time we come out one standard deviation from the mean on the right, we can add 3.4 hours, because each of those tick marks that represent a standard deviation, that means when we come out to the right, we should be adding 3.4, and then coming out to the left, because we're going to the left, every time we come out one standard deviation, we should subtract 3.4. So if I come out, and remember that a standard deviation roughly will be where we imagine that we go from concave down and then to concave up. So about right here is where I'm going to show that my first standard deviation lies. So if I come out 14 from the center, from 14 hours, and I come out one standard deviation to the right, that's going to give me 17.4 hours. And then I come out again, another 3.4. I'm going to add 3.4 again. That's going to give me 20.8. And then I come out one more time again, and that's going to give me 24.2. Now going in the other direction, I need to subtract. So coming out this way, I'm going to subtract 3.4 hours, and that's going to give me 10.6 hours. I'm going to come out again, subtract 3.4, and that's going to give me 7.2. And then one more time when I subtract 3.4 to come out 3 standard deviations, that's going to give me 3.8 hours. Okay, so remember all of these numbers here represent the number of hours that students study per week. Okay, now the empirical rule says if I come out one standard deviation in either direction from the mean, so here's the mean and I come out one standard deviation this way, 68% of the data lies in that area. So up here where it asks, part A, 68% of the students spend between blank hours and blank hours studying, that would be this 68% right here. So I would write 10.6 to 17.4 hours. Now the empirical rule says next, I'll use a different color. If I come out 2 standard deviations, so all of this area here underneath the curve between those 2 standard deviations, that should be 95% of the students. And that falls between 72 and 20.8. So in here where it says Part B, 95% of the students spend between, I'm going to put in 7.2 hours and 20.8 hours of studying. When we come out 3 standard deviations in either direction from the mean, all of that area under here should cover 99.7% of the data. So for Part C, where it says 99.7% of students spend between, those hours would be 3.8 and 24.2 hours of studying. Now, even though that the empirical rule only goes out to 3 standard deviations, just be aware that the graph keeps going like this. That doesn't mean that the graph stops at 3 standard deviations. It still continues to come out this way. There's just a little bit left under each of these tails. We went out to 99.7%, and remember the entire graph covers 100%. So what's left in these little tails is still 0.3% of the data